Hope you're doing okay today. We'll get started here in just a minute, but I know it's a bit random to be streaming about JavaScript on a Saturday morning early, but I usually do it on Fridays. But it's been a busy day at work, or a busy week at work. We had a big launch week, so I pushed everything off till Saturday. And what better thing to do than wake up early in the morning on a Saturday and stream about JavaScript? So hopefully you're ready for this. We're just going to walk through the next little section in Chapter 6. It's been a few weeks because of some travel for work and other stuff. So I am going to jump in live here with you as we get going. Let me switch everything over. Let's see. Here we go. Hey, good to see you. Hopefully you're doing okay today. I'd love to know where you're watching from. I guess this will be a smaller stream today, but we'll just jump right in. And we're going to start by looking at maps, which is where we kind of left off last time. So we've been in this chapter about objects, and if you weren't following along with us, that's totally fine. But this whole chapter, we made it all the way down to maps. We've been talking about classes and data types and prototypes and overriding, like, you know, the defaults. Private properties, we talked about that, overriding derived properties, and now we're into maps. Now, we've used maps before in JavaScript, and so I'm just going to jump straight in, by the way. And it's okay if you weren't with us before. We'll just kind of walk through this together. We talked about maps before, and this confused me when I first heard about maps because you have maps when you like loop over items, like you can map over something. This is different. This is a JavaScript map itself. It's used here, like I mentioned a second ago. They say in the previous chapter for an operation that transforms data by applying a function to its elements. So that's the method of map that lives on an iterator or an array. Here, as confusing as it is in programming, the same word is used for a related but rather different thing. A map, a noun, is a data structure that associates values, the keys, with other values. And maps are super flexible and super powerful. It's one of the things that I think the more I've worked with JavaScript, the more I've been like, okay, I need to use maps more. They just give you a lot of flexibility. Anything can be a key, anything can be the value, and so you can like put an object as the key, for instance. So you just get a lot of flexibility. So here they're saying you might want to map names to ages. It's possible to do objects like this. You've got a bunch of ages, then you've got people's names, and then their numbers. That's totally fine. And then you can just pick off the person's name, and that gives you back whatever their name is. So that does work. The object property names are people's names, and the property values are their ages, but we certainly didn't list anybody named toString in our map. Yet because plain objects derive from object.prototype, it looks like the property is there. In other words, this string right here, Boris, it inherits all this stuff from the object.prototype. For this reason, using plain objects as maps is dangerous. There are several possible ways to avoid this problem. First, you can create objects with no prototype. So you create this object, you give it no prototype whatsoever, and you can do that here by creating it as by using, if you pass null to object.create. So it doesn't then inherit all the stuff from object.prototype. We talked about that last time, which has again been a few weeks, and I don't know how many of us were here at that time, but usually whenever you create an object, it inherits all the stuff from the prototype itself, but you can create one without that if you want. Usually you want all that stuff because you want it to come along, but in this case you wouldn't, since it happens to be the key. So object property names must be strings. If you need a map whose keys can't easily be converted to strings, such as objects, you can't use objects as your map. Fortunately, JavaScript comes with a class called map, and this is what we're going to talk about here. This is written for this exact purpose. It stores a mapping and allows any key type of key. So you can have, like I mentioned, an object as a key. You can have anything you want as the actual key. And you declare this with the new keyword, and it's a class, and it comes kind of built in JavaScript here. So you can set let ages equals new map, and then you have a bunch of little helpers like getters and setters where you can set new items, and you can get items out of that. So here you would set it by doing this, and you would get it by doing this. There's actually maps built into a lot of the structure of kind of the way a lot of the APIs work in JavaScript too, so it's helpful to know even for that. You'll see this with like form data API comes back in this kind of structure. The methods set, get, and has are part of the interface of the map object. So you might remember, in fact, I think I've got code up here from last time. So you've got like, here's a class called student, and here we had a constructor, and I don't even remember what we were doing last time here. This is a private function or method available, and here's a public one. But you can see that what we've got is this would be like a getter, this would be like a setter, or whatever. These are attached to the actual map class itself. That's all we're saying here. So these are part of the interface of the map object. So writing a data structure that can quickly update and search a large set of volumes isn't easy, but we don't have to worry about that. Somebody did it for us. This is one of these things that people realized, hey, we should build this into JavaScript. Hey, welcome from Germany. If you don't have a plain object and you need to treat as a map for some reason, it's useful to know that object.keys returns only the object's own keys, not those in the prototype. So you can ask it for its keys, object.keys, and it will only return your own keys, not the prototype ones, so not the inherited ones. As an alternative to the in operator, you can use the object has own function, which ignores the object's prototype. Which I don't think I actually knew that. Object.has own, and you can ask what it has. Oh, interesting. Huh. Cool. Okay. And I wish they would do more with maps, because maps are super powerful. But maybe we'll get back to that. We can play around with it, I guess, a little bit too. But it basically gives us a structure where we can easily put data in it and get data out of it. And then it's just a nice way of working with a variety of types of data. And especially, like they mentioned, if your keys are not strings, if they're other items, it's really helpful to have something you can put it in that still works like a structure that's predictable. And you get nice APIs along with it, but maybe we'll jump into that later. All right, polymorphism. When you call a string function, which converts a value to a string on an object, it will call the toString method on that object to try to create a meaningful string from it. I mentioned that some of the standard prototypes define their own version of toString so that they can create a string that contains more useful information than object-object. You can also do that yourself. So here they've got this rabbit, which we declared up top here somewhere. I don't remember where that was. And they are grabbing the toPrototype.toString, and then they're just saying, hey, let's override this with our own function, where we basically just return this. Whatever the type of rabbit, like I think it was white rabbit or brown rabbit or something like that. So then it can tell us what this is. So then you can say, hey, turn this to a string, and it just says killer rabbit. So you can do that yourself where you're overriding this. This is a simple instance of a powerful idea. When a piece of code is written to work with objects that have a certain interface, in this case a toString method, any kind of object that happens to support this interface can be plugged into the code and we'll be able to work with it. This technique is called polymorphism. I should have probably asked, by the way, if like music and vocals are okay. I'm guessing they are because nobody said anything, but let me know if I need to turn one up or down. An example of a widely used interface of that array-like objects that have a length property holding a number and numbered properties for each of their elements. Both arrays and strings support the interface and do various other objects, some of which we'll see later in the chapter about the browser. So I don't know that I really want to jump a ton into this. You're not going to use, all it could say, you can like use this call method if you want to on it. I'm going to leave that alone. I don't know how useful that is at this stage if you're just learning about all this. All right, getter, setters, and statics. Interfaces often contain plain properties, not just methods. For example, map objects have a size property that tell you how many keys are stored in them. So it's not, maybe let's actually look at a map. Let's just create our own little map. So I'm going to get rid of all this because I don't even know what that was about. And here what we can do is we can this is not going to be a good example, but we'll do new map like this. And what we can do is just add a student to this. So that's fine. That's fine. Okay, so we've got a student here. And now we've mapped these different values, like their age, their favorite food, their current student. So if I want to, I could console log the student, and we could dot, let's do first of all keys, and then we can just see what keys we have available to us. Let's see, is this going to run? Let's do Quokka, run on every save for this file. Now we can get this stuff. Okay, so you can see here what I get back is an iterator. You might expect us to get just like an array of items, but you don't actually get that. And this can be kind of confusing when you're working with maps. because you expect to be able to get these values back. For instance, I might come in here and say values like this, values as well, and I get back an iterator. So it's useful, but you have to basically use these get set methods like age, for instance. So you've got to use this to get stuff out of it. This is usually when you interface with this is if you're not writing your own custom maps is with things like the form data API or other APIs in JavaScript that use this structure. You'll get back an iterator, or you'll get back, you want to loop over the values that it happens to have. And so you have to kind of know how to work with it. So here we've used a setter, we've used a getter. You can check this has property, and what you're asking is, does it have this key of age? But this could be anything. So again, let's come in here. We'll say student dot set, and I'm going to set, if I can get this thing to get out of my way, let's set it like an object. So that's fine. Student object name. Okay, so now what we're going to do is pass in this same thing where we pass in this name Chris. Oops. So you'll notice here that even though I'm passing in the same thing, because objects, like it's not going to check the depth of this, it's not going to be able to tell whether or not this is the case. So sometimes this is not as useful depending on what you're passing in, but I'm basically saying, does this thing exist? Now, let's see if I have like, let's see, a name object or something like that. All right, so let's pass this in instead. So we'll pass this in as the key, and then I can check off this and say, does this exist? Yes, that does, because it points to the same spot in memory. So this isn't like, you have to still know how this works. You can't just pass anything to this and expect to get the exact same thing back. But if it's a string, a number, a Boolean, those kinds of things, those kinds of primitives, you'll be fine. Otherwise, here what we're going to look at is just say, like, does this point to the same spot in memory? So you do have to be careful when you're referencing keys or things like that. But just another little note about how this map stuff works. I don't know why you got to that. Where were we at? Getter, setters, statics. Okay, so just to like play with the map a little bit, I think was all I wanted to do, instead of just reading this this text. I haven't been reading all of it. This book, as we've been going, I kind of like skim it and like we'll talk about it. But as we get more technical, I'll probably read more just to make sure I'm not messing something up and covering kind of everything they're wanting to cover. So it's not necessary for each object to compute and store such a property directly in the instance. They're talking about the size here. So like map objects have a size property. So I should be able to come over here. And if I have a size like this, this should just, this is just like a static method. And it tells me there's 4 items. There's 4 keys associated with this, which is cool. So it's actually telling me how many I have in here. It's like a length property kind of on an array. Same kind of idea. All right, it's not necessary for such objects to compute and store such property directly in the instance. Even properties that are accessed directly may hide a method call. So such methods are called getters and are defined by writing a get in front of the method name. Now, I don't actually know how many times I've done this, but you can basically write your own like this get size, and then instead of calling this as a method, which you would normally do, you just do dot size. And it says, oh, this is a getter. And instead of like it being a function you have to call, it just passes back the value, the result, the computed result of that value. So if I came back over here, we had this kind of thing over here, like get cap name. So let me console log all this out and we'll get all this back here. Okay, so here, I don't even know what this thing was. New student, I called all this stuff. Okay, that's fine. Let's return in here. Get cap name. So we're just going to return this dot. Do we not have a name? We'll just do this dot age. All right. And we'll call this get cap age. I don't know what this thing was. So normally if I were to call this and I did get cap age like this, I'd have to call it as a method, right? And this will return to me 25, but I'm actually invoking this method. Now, if I know this thing is always going to give me back essentially this computed value, then I can come in here and I can say get in front of this, and now I don't call this, I simply reference it as if it were just a static property, and you'll notice that it gives me this back. So these are the getters. This like get special keyword essentially allows you to do that, to assign a property name, in this case, this get cap age, to a particular function that returns the value, instead of it just being a hard-coded thing. So normally, if I had something like this on the class, like let's say age. Oh, I can't do age because I already have it up there. But yeah, you could basically have something like this either in the constructor itself or just as a static property in here, and you'd call it the same kind of way. But you can do that yourself with these functions using that get keyword. Hopefully that makes sense. All right, whenever somebody reads from the object size property, the associated method is called. So this is exactly what happens with the size and a couple of these other static like instances here, or static, I can't talk this morning, these properties, these plain static properties. Okay, so for instance here, we could have like a temperature class where we have a Fahrenheit and we have a set, Fahrenheit get and a Fahrenheit set. So here, if we're just getting it, then it would be .Fahrenheit, but you can use .Fahrenheit like this to actually set it. And in this case, what you're doing is you're calling this method, essentially, but you're passing it this, and it will take that value and basically provide that for you. Hopefully that makes sense. So you can use that same thing, .Fahrenheit to get and .Fahrenheit to set, and these determine this. So whenever you have like a structure that you would use the same kind of keyword for both in this case, you can use a getter and a setter to do this. Now you can do this in JavaScript as well. So like, I'm trying to think of a good example. I'm not going to think of one off the top of my head. Maybe they'll give us one in a second, but there are a lot of things that are both getters and setters, and this is how they do it in the structure of the class. They provide a get, they provide a set, they both have the exact same name, and if you just call it like a static thing here, it returns the get, and if you pass it something, like say it's equal to this, it uses the setter. So the class can kind of figure out intelligently which one to use. So it allows you to read and write the temperature in either degrees Celsius or Fahrenheit, but internally it only stores Celsius and automatically converts it from Celsius to Fahrenheit with the getter and the setter. So it's really helpful when you have like a data structure behind this where you have consistency in your data structure, but the interface you provide for the user is something that's a little bit more friendly to them. And then you do kind of all the magic yourself in these getters and setters. How much you use this in a class, I don't know that I use this a ton these days because, again, we're mostly into functional programming. It seems like in JavaScript. Hey, welcome from France. Thanks for joining. I like how like nobody else gets up at like 6 a.m. on a Saturday to talk about JavaScript in the US. So I usually just get people in Europe, which is cool. So thanks for joining me. Sorry, I'm waking up still. The temperature class allows you to read and write like we just saw. Sometimes you want to attach some properties directly to your constructor function rather than to the prototype. Such methods won't have access to class instance, but can, for example, be used to provide additional ways to create instances. Hopefully they'll give an example of that here. But in other words, you have properties you want, you don't want it to be part of your prototype, but the actual constructor itself. So we kind of saw that over here, these properties that we're going to pass in here. All right, inside a class declaration, methods or properties that have static written before their names are stored on the constructor. So here we were passing stuff in, but you can just statically do those as well. Do they give you an example? I don't know if they give you an example. Inside a class declaration, methods or properties that have static written before their names are stored on the constructor. For example, the temperature class allows you to write temperature from Fahrenheit to create a temperature using degrees Fahrenheit. Did they show that up here? Down here. So the static method here from Fahrenheit returns a new temperature, right? So you can actually pass in this Fahrenheit value instead of a Celsius value, and it does all this for you. But notice, because we've used this static keyword, it's immediately available to us when we actually call it here. Temperature from Fahrenheit to 12, and it actually will do all that conversion for us. Hopefully that makes sense. All right, so we looked at symbols a second ago. Yeah, I know it's like middle of the afternoon. Forgive my waking up here. I mentioned in chapter 4 that a for of loop can loop over several kinds of data structures. We've used them with arrays, I think, so far is all. This is another case of polymorphism. Such loops expect the data structure to expose a specific interface, which arrays and strings do. We can also add this interface to our own objects. But before we can do that, we need to briefly take a look at the symbol type. So the for of loop allows you to loop over items, and we've seen that. I guess in arrays and strings. I don't know if we saw it in strings or not. I can't remember, but it's possible for multiple interfaces to use the same property name for different things. For example, on array-like objects, length refers to the number of elements in the collection. So again, if I came over here, let's come up top here. We'll just have my array. And sure, that's fine. All right, so I could use the console.log, my array, and I want the length. And this is just going to tell me how many items I have. So I have 5 items. That's all they're saying here. So the length refers to the number of elements in the collection. But an object interface describing a hiking route could use the length to provide the length of the route in meters. So here we had down here like the size or whatever, but we could have a length. This is a map, but same idea. So my hike, and this could be like a length might be equal to, I don't know, 10 or something. So now if I came down here and I called console.log, my hike length, it's going to give me back 10. And that's because I've attached this like standard thing to it. So this length, in other words, they're referring to different things. This is something built in. This is something I've attached to my object here. Where are we at? Okay, for things like the iteration protocol, though, the language designers needed a type of property that really doesn't conflict with any others. So in other words, because they can like mean different things, you can assign your own values to it and stuff like that. They created something that could be untouched by people called the symbols. Symbols were added to the language in 2015. Most properties, including all those we've seen so far, are named with strings, but it's also possible to use symbols for property names. Symbols are values created with the symbol function. Now, usually you're not using this a ton. In fact, I don't know that I've ever written one myself. It's more like an understanding of how the language works. So unlike strings, newly created symbols are unique. You cannot create the same symbol twice. So here we've got a symbol where we pass in the name. They're console logging does sim equals symbol.name. So here they're kind of redeclaring it, and they don't. So they're always going to be unique, and that's kind of the value of symbols, and they are a primitive in the language. The string you pass to symbol is included when you convert it to a string and make it easier to recognize a symbol when, for example, showing it in the console. Now, the reason this is important because this interfaces with the way that we're going to be able to loop over things, create our own like attacher or an iterator. It's probably not the right way to say that, but it has no meaning beyond that. Multiple symbols may have the same name. So it's basically a way to be unique in the language with something you're declaring. Being both unique and usable as property names makes symbols suitable for defining interfaces that can peacefully live alongside other properties, no matter what their names are. So here we've got a symbol called length, and I can call array.prototype.length and get 0. And here I can take an array.length. I'm not sure what they're doing here. Do I understand this? Okay. So this dot length is going to give me the length like from the prototype itself. Whereas here, this symbol here that I've attached to the prototype called length, here will give me back whatever value I passed in here. And they're using this like bracketed notation because it's my own custom thing I'm passing in, which is what you always do with arrays or methods or things like that. Yeah, when calling this against a method or an object. I guess you wouldn't do that against, yeah, you could against an object as well if it's a value that you're passing in that's more dynamic. So it's possible to include simple properties and object expressions and classes by using square brackets around the property name. Again, we saw that with arrays and objects, I think, already in this book. That causes the expression between the brackets to be evaluated to produce the property name. So here, it's not the string length or the method call length. It actually says, let me evaluate what this is. It jumps up here, says, oh, this is a unique symbol. Let's see what it's set to. Oh, it's set to 0, and that's why we get 0 back here. That causes the expression between the brackets to be evaluated, like we just saw. So here we could have like a length. This is a static item that we have added to this object here. And we've got numbers. We've got this length itself, which I'm guessing they're pulling in from up here. And they're, I guess not, or they're setting it to that. Yeah. So here you can check on the actual length here to start with. And this is going to give you back this, right? Or you could check on the dot length, and that will give you this. So symbols basically allow you to have a unique thing. Even if it's named the exact same thing, it's unique. And that's what's important when it comes to iterators. So that was kind of the background of what we're going to talk about now. The object given to a for of loop is expected to be iterable. This means it has a method name with the symbol .iterator symbol, a symbol value defined by the language stored as a property of the symbol function. All right, so in other words, you have to have this method name to do this for of loop. The method named with the symbol .iterator, so it has to be an iterator. When called, the method should return an object that provides a second interface iterator. This is the actual thing that iterates. All right, hopefully this will make sense in a second with an example. It has the next method that returns the next result. That result should be an object with a value property that provides the next value. If there is one, and a done property, which should be true when there are no more results and false otherwise. This actually reminds me a lot of generator functions too, like the way this works, which I don't know if we'll get into or not. But I want to get more into them because I think they're super cool. Anyhow, all right. Note that the next value and done property names are plain strings, not symbols. Only symbol.iterator, which is likely to be added to a lot of different objects, is an actual symbol. All right. So in other words, when you have an iterator, here the symbol.iterator, you can call the next, and you should always get back here a value and a done. And these tell you, okay, what is the value that I have? Here it's O, here it would be K, and then eventually you'll get undefined and the done is true. And I don't know how connected generator functions are to this actually. I actually don't know that, but this is, like I said, very similar to what happens when you define a generator function and you call whatever that keyword is. I can't remember right now. All right, so let's implement an iterator data structure similar to the linked list from chapter 4. So we'll write a list as a class name this time. So here we've got a list where we take in a value and a rest, and we set these to value and rest as in the constructor function. Then we've got a getter that just gives me my length. So it returns 1 plus all this stuff. And then we also have a static from array method that gets loops over those items. So we've got array.length. So this is just a simple for loop where we basically have an array and a result, and we return the result. I'm not totally sure what this is doing. All right, let's see what they explain this and if my brain can wake up in time to figure out what's going on here. Note that this is a static method pointing to the constructor of the class, not an instance. There's no instance around when a static method is called. All right, so you remember we've got these kind of instance methods here, or instance things we can pass in that are unique per item we pass in, and then all the rest of these are going to be like always part of the class itself. So these will not be unique. This one will be unique. Obviously, if they interface with our numbers, then they'll have their own, they'll provide different values based on whatever the instance is. But you can see here that these are going to be the same for every single time we call this list, or we create an instance of this list. All right, note that this is a static method, points to the constructor of the class, not an instance. There's no instance around when a static method is called. Iterating over a list should return all the list's elements from start to end. So let's write a separate class for the iterator. So here we've got a class, a list iterator, where we pass in a list. And here we pass back a next function. And this is one of those things you need. And notice it's going to pass back done and true, and then the actual value down here. So this is basically what we can attach to our own class to create our own iterator. And this allows us to use something like the for of loop. The class tracks the progress of iterating through the list by updating its list property to move to the next object whenever a value is returned, and reports when it's done. So you can pass in a list, and then you can basically get back each time you come in here this next function like we saw up above here, where we're going to call next, and it will slowly iterate through your list, and by the time you're done, it will then return back done equals true and undefined for the value. All right, so now we can basically use this. So let's set up the list class to be iterable. Throughout this book, I'll occasionally use after-the-fact prototype manipulation to add methods to classes so that individual pieces of code remain small and self-contained. In a regular program where there's no need to split code into small pieces, you declare these methods directly in the class instead. So here you declare this as a function, new list iterator, and you pass it that class that we just created. Now we can loop over a list with for of. And the reason you can do this, list.from array here, and then we can pass over this element of list right here, is because of we've defined this same kind of structure. We've made it into this iterable. And a loop always requires an iterable. So the syntax in an array is dotted syntax right here. Is an array notation and function calls similarly works with any iterable object. So you can use the spread syntax anytime you have an iterable. And it essentially mimics the same structure we just saw up top here. And it's just looping through each of those items and spreading them in. So for example, you can use ... value to create an array containing elements and an arbitrary iterable object. So you can do ... PCI, and it will create the object like this. The reason it can do that is because this has like this structure of an iterable underneath. Arrays, objects do, and you can create them yourself in your own class like this. I don't think I've ever done this, but you can. All right, and at least explains like how the whole thing works under the hood, if that makes sense. I feel like this is like fairly, maybe not advanced, but like just obscure. So it's interesting to me that the book's covering it, but it's fine. All right. Inheritance. All right. I think we're getting close to the end of this, and maybe we'll play around with like a form data API just to kind of see how maps and iterators work in like a real life situation. So imagine we need a list type, much like the list class we saw before, but because we'll be asking for its length all the time, we don't want to have to scan through its rest every single time. Instead, we want to store the length in every instance for efficient access. So in other words, we want to know the length for each instance of this class. Each time we've declared it, we've instantiated it. JavaScript's prototype system makes it possible to create a new class, much like the old class, but with new definitions for some of its properties. Now, this is one of the things you'll see in JavaScript is it's very flexible, which is great. However, because of its flexibility, you end up like, there are a lot of foot guns you can like easily use. So it's nice that you can create this prototype system allows you to basically just tack on new things, but just be careful with it. The prototype for new class derives from the old prototype, but adds a new definition for, say, the length getter. So in object-oriented programming terms, this is called inheritance. The new class inherits properties and behaviors from the old class. So we've got a length list, extends list. This right here, this structure, what we're saying is, hey, I'm going to take list, and I'm going to extend it with this extra little value. Now all these will get it as well. So length list from array.length, this is going to get the getter from this. So it's extending it. You can like attach it to it. We've seen this before with like this kind of idea where you can basically inherit stuff from like a parent. I think a little bit when we were working with the DOM, but this is all that's happening under the hood. So you can have a class that extends another class, that extends another class, and that way you can kind of keep your logic tied to that particular class and use it in other areas where you want to. The use of the word extends indicates that the class shouldn't be directly based on the default object property, but on some other class. This length list, and we've given it, this name length right here. That's interesting to me that they've got this. I'm not sure why this thing is marked as a private, I guess because maybe you have to override this. Let's see, maybe they're going to describe it down here. I'm not actually sure why they did that. This is called a superclass. It derives from the subclass to initialize a lengthless instance. The constructor calls the constructor of its own superclass through the super keyword, which I'm guessing they'll show below. Maybe not. All right, so you can use the super keyword to connect to that inherited value or inherited class. This is necessary because if this new object is to behave roughly like a list, it's going to need instance properties that lists have. The constructor then stores the list's length in a private property, right here, this private property. If we had written this .length there, the class's own getter would have been called, which doesn't work yet since length hasn't been filled in yet. We can use super.something to call methods and getters on the superclass's prototype. So sometimes you don't want it on your instance, you want it on the actual like super, and so you can use that super dot whatever the method call happens to be. Inheritance allows us to build slightly different data types from existing data types with relatively little work. It's a fundamental part of object-oriented tradition alongside encapsulation and polymorphism. Again, like a lot of JavaScript programming right now, is much more functional. So usually you'd write these all as separate functions, but there's a lot of the world still runs on this object-oriented approach. There's a lot of languages that are built basically exclusively with this kind of thinking, and I don't know if I'd say it's like a more refined system, but it's definitely been around long enough to be really established. So it's important to understand these concepts, even if you don't write them a ton in JavaScript today. Although maybe you do and I just don't, and maybe I should more. Inheritance allows us to build slightly different data types. We just saw that. Well, the latter two are now generally regarded as wonderful ideas, and inheritance is more controversial, and that's mostly because of the footguns. Encapsulation and polymorphism can be used to separate pieces of code from one another, reducing the tangledness of the overall program. Inheritance fundamentally ties classes together, creating more tangle. Let's see, VS Code, theme, and font. I don't know. I think this is called Vercel Dark or something like that. And the font might actually be that Vercel font. Nope. Actually, I think it may be. Let's just check. I changed it recently for something. I don't remember why. SF Mono. Yeah, so it's just SF Mono from Apple. All right. Instance of operator. All right, and then we're done, and then we can play around a little bit. All right, it's occasionally useful to know whether an object was derived from a specific class. For this, JavaScript provides a binary operator called instanceof, where you can check to see, hey, was this like derived from this class or that class or whatever it happens to be. So let's say I have a class called lengthList, and I want to say, like, is this an instance of that? Yes, it is, obviously. And here you can have like just a list and ask, is it? No, it's not. All right. Now, this isn't super helpful because I can obviously see that, but there are other times where you'll get back something and you want to check, is this an instance of whatever this class is? And instance of is something you'll use. Usually for me, it's not so much of my custom stuff. I use it more to like check if things are an instance of whatever class I happen to be referencing that's built into the language. The operator will see through inherited types. So a length list is an instance of list. The operator can be applied to standard constructors like array, and that's usually where I use it. Almost every object is an instance of object, which usually isn't very helpful. So here we've got a length list. We can check if it's an instance of list, and it is because of inheritance, which again is a little bit more controversial because of the footguns. All right. Oh, we got some exercises down here, which I did not know. Oh, this is funny. I don't know how much I want to go over this. I think I'd rather use something you're going to use more, which would be like a form. So maybe let's do that instead. And I think I've got, what do I have in here? Nothing. Okay. So let's do index.html. Let's just get something up here. I feel like I'd rather, get you something that you'll actually use. So let's use a form and oops. Let's give this thing an ID, if I can type. I don't usually have whatever this is, GitHub code on, so custom form when I'm doing live streams and stuff, because it just gets in my way. But in this case, I think we'll allow it because it would be nice to have this. All right, so importantly, we've got the name right here, and we happen to call it name, but you can do whatever you want. This name declaration allows us to use the form data API. And when we do that, the form will pass back anything with a name property on it. And it will give us that in a map. And so we'll be able to interact with it that way. So why don't we let's come down here. Let's just write an inline script. And let's see what it will give us. Cool. Okay, so I don't want to do all this. This would be kind of like individually grabbing each item. Well, that works great when you have one item. But what I would rather do is to say, let's get all of this. And we're going to call this form data, and we'll get this from new data form. So this right here, this instance of this form data class allows me to instantiate this, where it basically gives me this back in a map is all it's getting. And notice I've got form data.getName, but I can also just pass this to some kind of method and do something else. So let's come in here and let's first of all console.log this, and you'll see here that what we're going to get is not as helpful as you might expect. You might expect just to get this back as like a list, like an array or something like that. All right, so let's go live here, which will spin up here. This will work. Right, so I've got this form, And if I look inside here, oh boy, maybe I need to rearrange my windows here. But if I say like Chris and I hit submit, this should give me back here form data. But notice this is not super helpful, right? I'm just getting back this, iterator, but I need to actually pick off something from here. So there are a couple ways to kind of adjust for this. So if I come back into here, instead of getting, I don't know what this is. All right, instead of just console logging this, what we can do is use object.from entries, and we can basically say, give me all the entries, or give me all the keys, or give me whatever. But notice I'm using this dot entries or dot keys or dot whatever, and then I'm passing it to this object.from entries, where I'm actually getting back like this as an object. So now when I actually run this, let me go back to Art because I guess that's where it's at. Here we go. I can say Chris, and here we get an object that has the actual keys and values associated with it. So all this is happening using the form data API. So this is usually where I interact with things like maps. So we've got a getter and a setter. There's also sets, which I don't remember if we've looked at yet or not, but they give you unique values, but they use the same kind of structure. Now you may notice that here we have form data, or I can use the for of loop here. Yeah, so notice here, it's actually picking these off. This is picking all this off, and it can use this structure because it's an iterator. So I can use the for of loop because it can go through and it basically uses that internal call that we saw of next and done and all this to figure out, like, do I have another thing to loop through? Here I'm passing in the entries. This is a little bit more complex because I'm actually destructuring these as name and value, and then I can console log these for each item inside of here, which is basically what we just did a second ago with the object.from entries. But all that to say, usually when you interact with maps, you're doing them inside of something like form data API. So hopefully that's useful. All right. I think we'll call that good. Let's just preview the next thing. We'll do this, I think, next Friday. And that would be a project. Oh, cool. We get to work on a project called Robot. So let's preview this real quick. Okay, so we get this project where you have to do certain things. We have a task. I don't know. Should we try to do this live? Why not? I don't know if, it could be more complex where I need to actually do it first and then do it with everyone live because I don't want to waste everyone's time. But mostly in this book, I've just been reading it straight and explaining as I've gone. But I also don't want to get to a spot where I can't even do the thing. Because that's not super useful. So if I do, I'll let you know. Usually my lives are genuinely live. But if that changes and I happen to do this ahead of time, I'll try to let you know. But yeah, hopefully that was helpful today. And thanks for following along. Trying to switch to my camera. Okay, cool. Hey, Fuzzy, welcome. Hopefully your day's been great. Mine's kicking off okay. But yeah, hopefully you all have a great rest of your day wherever you happen to be. And thanks for following along today. It's good to get back into Eloquent JavaScript. And we'll try next week to do this sample project about the robot or whatever. All right, see you then. Thanks.